equation of the lines, and we're going to look at specifically parallel and perpendicular lines. Let's look at these things. So two lines are parallel if M1 equals to M2. And if they're perpendicular, M1 times M2 equal to -1. How do I remember this? Very easy. Just remember parallel lines looks like an equal symbol. That's the equal. Whereas the perpendicular line looks like the times symbol. So that's how you remember which one's equal, which one's times to get -1. Okay. Deciding if the lines are perpendicular or parallel or neither. So what you do is you look at the first question, you find the gradient. Now how do we get the gradient? Is the number in front of x when y is the subject. So this is half, which I will highlight. Oops. Okay, highlight this bit. But you don't take the x with you, just the half. So m1 is equal to half. m1 equal to half. And then you go, oops, why is it like this? M1 equal to half. And M2, you have to make y the subject. So you go 2y equal to x plus 5. Y equal to half x plus 5 over 2, which means M2 equal to half. Oh, they're equal, isn't it? So you write, therefore, M1 equal to M2. And what conclusion do you make? They are parallel. They are parallel. I'll try the next one. Next question. Next one's a bit easier. You just write M1 equal to -3. M2 equals to 3. A third and a one -3. And then they're not equal, and you just check. What if you multiply them? Do you get -1? If you do, that means they must be perpendicular. And you get -1, isn't it? You can use your calculator or you do it by hand, -1. So you write, therefore, two lines are perpendicular. Alright, get the idea? Alright, try the last one. You have to make both y the subject. So you have to do some work before you find the gradient. Alright, good. Alright, so let's try this. So you go 2y equals to -3x minus 5. Y equal to -3 over 2x minus 5 over 2. And then what do? You get m1 equal to -3 over 2. m2, you have to make y the subject as well. Let's do that. So you get x equal to y plus 2. Y equal to x minus 2. And therefore the gradient of the second one is 1. Now, if obviously they are not the same, m1 not equal to m2, and if you try to multiply them, it doesn't work as well. You just get -3 over 2, which is not equal to -1. So the product is not -1. They are not equal to each other. Therefore, you conclude they are neither parallel nor perpendicular. Parallel nor perpendicular. Alright, so now we know how to check whether lines are parallel or perpendicular just by calculating their gradient. Next, we're going to find the equation given they are parallel or perpendicular. So let's do that. So note the working. So it's very important you show the working how you got the gradient first. Then you have to say whether they're equal or perpendicular based on your calculation before you make a conclusion whether they are parallel or perpendicular. Okay, after you do this, we're going to do the next two examples, which involves you finding the equation of a line. Alright, let's look at this. So we'll do one that involves parallel, do one that involves perpendicular. Okay, let's look at the first one. The first one says, find the equation of the line that is parallel to -2x minus 7, but pass through this point. So to find the equation of the line, you do two things. The first thing you do is find the gradient. And since the gradient of the first line is -2, because they are parallel, m2 equal to m1, which is equal to -2. So we've got the gradient of the line you are finding is -2. And you pass through this point, x1, y1. You use the formula y minus y1 equal to mx minus x1. Let me write this again. Y minus y1. Okay, good. Alright, so what you do is you do y minus 9. This is your y1 equal to the gradient, -2, bracket x minus 1. The point gradient form, because I don't have the y-intercept, I only given a point and the gradient. Because their lines are parallel, the gradient are equal. Both are -2. So now you just have to expand this, so you get this again, -2x. Why is it not working? Okay, let's knock this off. Okay, good. So -2x plus 2. And move the -9 to the other side, so you get -2x plus 11. Because -9, you add 9 to both sides. 2 plus 9 is 11. Okay, good. That's the equation of the line. So you'll see that they both have -2 as the gradient because they are parallel. All right, good. Any question? All right, good. How about the next one? The next one exactly the same. This time it's perpendicular to it. So you need to do a bit of work. So you say m1 is 3/4. M1 equal to 3/4. And then you're going to write, let me just drop this off. So if they're perpendicular, the product is -1. So m2 being perpendicular to it will be, the product is -1. And you have to solve for the second gradient. So you do m2 times 3/4 equals to -1. And to find m2, you can multiply both sides by 4, which cancel this 4. You'll get -4 and then divide by 3. So write m2 equal to -4/3. Now you don't have to do all this work. All you have to do is to reciprocal 3/4, which become 4/3, and change the positive to negative. So you just have to do the negative reciprocal. But if you don't like this idea, you can always use this formula to work out the second gradient. Now we got the gradient, and we don't have the y-intercept, which is 3 minus 2. So what you do is you use the point gradient form like before. Y minus y1 equal to mx minus x1. That's a very convenient formula to find the equation of the line, because you only need the point and the gradient, and the point is y minus -2 equal to the gradient x minus 3. And then you just have to expand and simplify. So you get y plus 2 equal to -4x/3 plus the 3 and the 3 cancel, you get 4. So your answer will be y equal to -4x/3 plus 2 is your equation of the line. So this line will be perpendicular to the other line passing through this point. All done. Any questions? So you can start exercise 5H today. Thank you.